for that Voronoi fracture, here's what we're after in general. We have all these pieces right here. The Voronoi fracture happens after we get done with that Boolean plane section right here. And really, there's nothing special to it. I turn things into a VDB, scatter some points. I use the iteration right here with the random function. Set that between 0 and 4 so that there's always either 0 points or 4 points for each iteration. Voronoi fracture. And we are now here. Also, we really haven't talked about the name attribute and what we're doing for this. So instead of going up here and trying to figure out how to group the Booleans and keep track of the name, as we did over here, there's actually another way you can organize this that might just be easier for you to do anyway. What you do is you rely on the measure SOP. This SOP is amazing for all kinds of things. And we take the volume and we use that volume to create our primary, secondary, and tertiary groups. So I'll situate this before the assemble real quick. So we'll go like that. And I want to find the middle value and say maybe anything that's over the middle value is primary. So we'll start there. If we go and select this little multi-widget right here, that'll create this visualization. Be careful because this could crash. I found it's a little bit buggy sometimes. But you say per piece. Right now we're just using class. And so actually really be sure that we are doing this properly. Connectivity right there. Be sure that we regenerate that class. Okay. Also, with the connectivity, I set this to primitive. I'm not sure if the measure is looking for a primitive or a point attribute. Sometimes it's hard to remember what's looking for what. So to play that safe, we can just do an attribute promote from primitive to points. And again, we are doing class. So we do that just to play it safe. The same infos on both spots if you uncheck the delete original. This has caused many a heartaches, many a broken hearts that delete original. So watch out. The normal SOP. I facet everything so that I can see what's going on. Then I measure it. And now with our measure, we can be sure that we have a good thing going on. Now on the point wrangle, we can now say something very straightforward. If at volume is greater than 0.01, then that's pretty cool because now name is equal to, let's say, P for primary plus, let's see here. We can just do at class. Well, we'll say ITOA at class. Remember, that turns it into a string. And that's it. Oh, and to double check that, also CD equal to curly brackets 1, 0, 0, so that it's red. Right now it's not working because this point wrangle actually needs to be a primitive wrangle. There we go. Looks awesome. So there's our primitives. They're red because the volume's over 0.01. Let's actually do 0.035 though, or whatever value that you'd like. So that's cool. Now we could do the same thing for secondary. Copy paste that and say if it is less than that value, then, or less than or equal to, we could actually have something equal 0.035. If that's the case, then this will go green. See if that works. So far, so good. And also, we want another stipulation here. And at volume is above something. So if volume's above, let's say 0.001. So as you can imagine, 001 is going to be our tertiary size. So now, if the volume is less than or equal to 0.001. Great. Now this is blue. And you might just want to save this wrangle out in the future. Just, if you end up doing this a lot, you don't want to type all that out. But I just want to show you that we can, in fact, create really cool groups. Also, don't forget to say secondary and tertiary right there. It's important. The main thing is that we don't really keep track of, which fracture these pieces came from, but that's okay because we only care about the size. And so we basically just have a P, S, or T plus the class. So that's another way you can organize things if you'd like. And after a few nodes and lines of code and a little bit of magic, we end up with something like this. Now, look, your plates are going to react differently than mine. So you need to go through and adjust these settings for yourself. What you're looking at right here is the setup that's just been tweaked a little bit here and there so that I tried to dial in the right seed on the scatters. And, I went back and I've messed around maybe with the seed on the Voronoi fractures, things like that until I was satisfied with what was going on. So this might take a few rounds of, again, dialing things in, but get it to a point where you're moderately happy with it. This also, by the way, is subject to change, even on my end here, until it's all said and done. But right now for the course, I'd say it's time for us to move on to the detailed pass. That's particles. We'll get into some smoke stuff and also some instancing. And that should wrap up this super mega awesome course.